Alright, so what we'll do here is see how you can take some points, plot those points on a grid, and you can actually derive or get the equation of the line from the graph. So let's look at A first. I've got a table of values here, and I've got 3 values. You only actually have to plot 2 points to join them up and make a line, but you're supposed to do 3 just to prove it is a line. But we'll just do 2. We're assuming we're working with lines here, so 2 is good enough. So 0, 4, that's 0 along the x-axis and 4 up. So there's 0, 4. 1, 2 is 1 across from the origin and 2 up. So there is 1, 2. And you can join those points up to make your line. Merry Christmas, I've lost my ruler. And what you can do with this is either from the table of values or from the line itself, you can get a slope. Now here I can see quite a nice triangle from these 2 points here. You can see that this is 1 across and 2 down. The other way of actually deriving the slope is saying I'll do y2 minus y1, or the vertical change, over x2 minus x1. That's the horizontal change. So x1 and y1 is always the point on the left, x2, y2 is the point on the right. So I'm just going to say I'm basically doing 2 minus 4 over 1 minus 0, and you can see that this has a slope of -2. Also, because you had the y-intercept, you know when x is 0, this is 4. In the equation of a line, mx plus b, you know that this is the slope and this is the y-intercept, right? Well, we've got the slope in this one is -2. We also know the y-intercept is 4, so we can just write the equation of this line is -2x plus 4. We can do the same process for line B here. That's line A. Let's look at line B here. Line B, I got 1, 3. So 1, 3 is there, and 2, 3.5 is there. So line B is connecting those 2 points. Looks like that. This one I could actually derive the B value from the graph. Actually, that's not a greatly drawn graph, and it's not super accurate, but it should be at 2.5 there. So this should be 2.5. So for B, let's look at mx plus b, the equation of the line. We know that the slope, actually you can tell from the differences here, right, that you're going up by 1/2. So you know the slope is 1/2. For every 1 you go across, you're going up 1/2 unit. You can imagine that like this, right? Along the corridor, up the stairs, as we sometimes remember it. The b value is 2.5, so you can put that in there. The slope is +1/2. So that's the equation of line A. That's the equation of line B. You can actually show that they're perpendicular, because if the slope 1 is -2 and the slope of line B is +1/2, that's the same thing as that. When you multiply those slopes together, you get -1. So the product of those is -1. This means that they are actually perpendicular. So they are at a right angle to each other, or they're supposed to be. I haven't drawn those lines brilliantly, but they're supposed to be perpendicular at a right angle to each other. You can also just read off from the graph where they intersect each other. So again, graphs are not as good as algebra, but I'm sort of broadly or roughly seeing that the intersection is at about x equals 0.5. That's got to be below that line a bit, but it's maybe at 2.75 or something like that. In a later lesson we'll look at how to show this point more accurately using algebra.